Now we've got the idea of being able to generate guesses for things, building on this idea of iteration. If we think about the code we just looked at in the previous segment, while loops generally iterate over a sequence of choices. And often, especially in exhaustive enumeration, that sequence of choices is a whole series of things in order. In the examples we've seen so far, they've all been ints or integers. If we're doing that kind of iteration, that kind of loop over a sequence of choices, Python provides a very nice specialized mechanism for handling this, and it's called a for loop. And the idea of a for loop is, well, first of all, let me talk about the syntax of it. It has the following form. There is the special identifier for, and then some identifier. This will just be a name of something, so I put it in these angle braces to indicate. That could be, for example, for n. And then the keyword in, and then some sequence, some collection of choices, followed by a colon, and then indented a code block. So as before, this is going to tell us the things that we want to do, that code block, and that's the form of it. Here's the basic idea behind a for loop. That identifier is initially bound to the first value in the sequence. The code block is then executed. The identifier is then bound to the next value in the sequence, and that code block is executed. Now, if we stop here, you may get worried. You say, well, aren't I going to go through all possible choices in the sequence? And the answer is yes. I'll do that until I either run out of choices or until I hit a special keyword called break. When I hit a break statement, it pops me out or stops me from computing things inside of that for and takes me to the next piece of code. So break will be a way to tell me, based on some test, when I actually want to jump out of the code. All right, we're going to look at an example of a for loop in a second, but there's the basic idea. I'm simply going to walk down the sequence of choices, doing something until I get to a test that causes me to hit a break or I run out of possible choices. Got one more piece. How do I generate a sequence of integers? If that's what I want to do. I could generate sequences in a lot of cases, but in many cases, as I've seen, I'd like to do everything from, say, 0, 1, 2, 3, 4, up to some point. And for that, I've got a built-in function called range. And range with one argument n, notice it's in between those parentheses there, will give me the sequence of integers from 0 up to, but not including n. If I want to get a sequence starting at some other point, I can give range two arguments, m and n, and it will give me the sequence of integers, m, m plus 1, all the way up to, but not including n. With those two ideas, let's see what happens if we go back and clean up our cube root finder. Here's the code. It's similar to what I had before, right? But it's now a little crisper, and that's a good thing. Again, I want to have something that tells me, or asks me rather, for an integer that I'm going to deal with. I'll input it and to make sure it's an integer by doing a cast or a type conversion on it. And then notice the for loop right here. There's my identifier, for answer, ANS, in, and there's range. So notice what range is going to do. It's going to generate a sequence of integers, 0, 1, 2, all the way up to the absolute value of x. The for loop says, for answer in that range, starting at 0, I'm going to execute the body. Notice the form of the body. The body has a test. And if the test is true, it's going to hit a break. So there's our form, right? There's the generate step. And there's the test step. Or if you like, the check step. I'm going to, in turn, have answer take on the values 0, 1, 2, 3, etc. up until x. Once I get past x, I'm going to stop. But inside of that loop, I'm simply going to say, let me check. If answer cubed is equal to absolute value of x, the thing I'm looking for, I'm done, and I'll hit break. And when I hit break, it throws me out of the loop and takes me down to the next piece of code. And in that case, I'll now check. Now, why do I have to do one last check? Well, I don't know whether I hit a break or whether I actually ran out of values to try. So I'll see which case I'm in. If I'm in a place where I'm out of values, in other words, if answer cubed is not equal to the absolute value of x, which meant that this test was not what caused us to get there, I'll return the fact it's not a perfect cube. Otherwise, well, I'll just do what I did before, make sure I know which sign I want to use and then print out the right thing. Let's check it out. Over here in idle, there's my code. It's got all of those pieces. And if I now just run this, it's going to ask for an integer. Let's give it my good old 27. There it is. Let's try it again. And let's give it minus 27. And there it is. And let's try it one more time. And I don't know, we'll give it something more interesting. Okay, I probably knew that wasn't a perfect cube. It's pretty efficient code. And so what is this doing? It's generating a sequence of options exhaustively by using range to do them one at a time as I need them. And inside of each, it's doing a check to see have I found the value I want or not. And with that generate and check idea, I can write actually a piece of code that does a nice job of finding the things I want. We're going to build on this idea as we move on.